So last time we defined a derivative and did some activities to see how to calculate derivatives of some elementary functions. So today we'll begin with discussion on slopes and tangents, and then discuss the rules or methods of differentiation. So tangents and slopes. So because it may not be possible for you to scroll your phone and write and listen at the same time, so I encourage you to just write down some key highlights. But at the end of the class, I'll share the notes and the recordings for you to join up your work. So you need not to write everything as we continue. What I encourage you to do is to listen and ask things which are not very clear. But in terms of updating your work, you can do it after class. I'll share the notes and the recordings later. All that's in order. Is that okay? Yeah, fine. So with your paper or a pen, you can just write a few highlights, but then in terms of the flow, you can do that one after the class, because it's sometimes very difficult to multitask, scrolling your phone and writing and listening and understanding at the same time. So begin with the examples here. So the first example, find the slope and the equation of the tangent to the curve y equals to x squared at x equals to 2. So the first thing we recall slope which we denoted by m, we said is the same as derivative. Now at this point, we have point at x equals to 2, which will be the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. Because remember, we say that the slope of a function f of x at a point x equals to a is simply denoted by m, which is given by the limit as h approaches 0, f of a plus h minus f of a over h. Now our h, our a in this case. So f of 2, I remember when you say y equals to x squared, the same as f of x equals to x squared. So f of 2 is the same as 2 squared. So 2 squared is 4. And then when you say f of 2 plus h will be the same as 2 plus h squared, which is the same as 4 plus 4h and then plus h squared. So which means then m, which is the slope, is limit as h approaches 0. Now f of 2 plus h is 4 plus 4h plus h squared minus f of 2, which is 4, divided by h. Now here we see this 4 and minus 4 cancels out. So I'll have limit as h approaches 0, 4h plus h squared divided by h. Now the numerator h is common. Then you can say m equals to limit as h approaches 0 of h into 4 plus h divided by h. I've simply factored out h. Then you cancel this and this. So we'll have limit as h approaches 0 of 4 plus h. And then what will be the value of this limit? What is the value of the limit here? The limit will be? What is the value of the limit here? Four, correct. So the value of the limit will be 4. Good. So this will be 4 because this is simply 4 plus 0, which is 4. So therefore the slope is 4. And then the equation of the tangent is given by y minus f of f at 2 m into x minus 2. So f of 2 is given by 4. So we'll have y minus 4. Our slope is 4 into x minus 2. So this is the same as y minus 4 equals to 4x minus 8. Then, which implies when you arrange in the form y equals to mx plus c, you'll have y equals to 4x. Now minus 4 will be plus, so minus 8 plus 4 is minus 4. So this will be the question of the tangent. Then example 2, find the slope of the graph of f of x equals to 2x minus 3 at the point 2, 1. Everything stems from the definition. So remember, when you are giving a coordinate, the first number is always the x value. So this is always the x value, and then this is the y value. So it's like our x value is 2, so our a value is 2. So as usual, the slope m is limit as h approaches 0 of f a plus h minus f of a divided by h. So in our case, a is 2. So therefore, this is the same as limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. So the function here is 2x minus 3. So f of x is 2x minus 3, which implies that f at 2 will be 2 times 2 minus 3, which will give us 1. Then f of 2 plus h will be 2 into 2 plus h minus 3, which will be 4 plus 2h minus 3. And 4 minus 3 is 1, so the same as 1 plus 2h. So that your slope will be limit as h approaches 0. F of 2 plus h is 1 plus 2h minus f of 2, which is 1, divided by h. Then 1 and minus 1 cancels out, so this will be limit as h approaches 0 of 2h over h. Then this and this cancels out, and this limit will just be 2. So therefore, the slope of this function at the point 2, 1 is simply 2. Then let's give more other example on this. So find the equation of the tangent of the function number 3. Find the equation of the tangent and normal to the graph of f of x equals to x squared plus 1 are the points zero, 1 and minus 1, 2. So the first thing will be to find the equation of the slope at each of these points. So remember, solution at the point 0, 1, what is our A value? 0, correct. That's the x value, 0. So therefore, the slope of the tangent at 0, 1 is m limit as h approaches 0 of f of, now our A is 0, so it will be 0 plus h minus f of 0 divided by h. I remember in this question, f of x is x squared plus 1. So here, f of x is x squared plus 1. So which means that f of 0, where there's x, we put 0. So I'll have 0 squared plus 1, which will give us 1. And f of 0 plus h, and now this just be the f of h, will be the same as h squared plus 1. So 0 plus h remains to be the same as h. So m will be limit as h approaches 0 of h squared plus 1 minus f of 0 is 1. divided by h. So 1 minus 1 is 0, so this will be limit as h approaches 0 of h squared over h. Then h squared over h is just h, so this will be limit as h approaches 0 of h. And finally, the value of the limit will be so when you evaluate that limit, you get just unmute and say 0, correct? Yeah, so they have 0. So the limit will be 0. So the same the slope of the tangent is 0. So equation of the tangent at this point, now we'll have y minus f of 0 equals to m into x minus 0. So that f of 0 is 1. So I'll have y minus 1. Value of m is 0, so 0 into x minus 0. So we just be 0. So y equals to 1 will be the equation of the tangent line. Then for normal, at the same point, we know that a normal and tangent, if you have this as our curve, our arbitrary graph y equals to f of x. So this line so this is what we call tangent with respect to this curve at this point. Then a line which meets this tangent at 90 degrees is what we call the normal. So the slope of the normal times the slope of the tangent at any given point should give you -1. That's properties of equations of perpendicular lines. So m1 times m2 should give us -1. So 0 being the slope of the equation, slope of the tangent, then times m2 equals to -1. You see this will give us 0 equals to -1, so which is absurd. So for this case, normal does not exist. So this normal doesn't exist for this case. Now the other point is -1, 2. So -1, 2, our a value is -1. So which means then the slope of the tangent will be limit as h approaches 0 of f of -1 plus h minus f of -1 divided by h. So f of -1 will be given by -1 squared plus 1, which will be 1 plus 1, which is 2. And then f of -1 plus h will be the same as -1 plus h squared plus 1. So which will be -1 squared is 1. Then plus h squared. Then -1 times h is -h times 2 is -2h. Then plus 1. So this will be 2 plus h squared minus 2h. so that your m will be limit as h approaches 0 of 2 plus h squared minus 2h, then minus 2 divided by h. So this positive 2 and minus 2 cancels out. So this will be limit as h approaches 0. Now h is common, so you can say h into h minus 2 over h. So this and this cancels out. So that we'll have m equals to limit as h approaches 0 of h minus 2. So when you work out this limit, it reduces to minus 2. So then now equation of the tangent is given by y minus f of a, and our a in this case is minus 1, equals to m into x minus a, and so minus minus is plus 1. So f of minus 1 is 2, so we'll have y minus 2 equals to minus 2 into x plus 1. Then we'll have y minus 2 equals to minus 2x, then minus 2. So which simply is y equals to minus 2x, because now minus 2 plus 2 is 0. Then you can get the equation of the normal by simply saying that the product of the slopes of the tangent and the normal is minus 1. So given that the tangent has a slope of minus 2, then this means that the normal will have a slope of a half. So then now the equation of the normal will be given by y minus f of minus 1 equals to m2 into x minus minus 1. So we'll have y minus 2 equals to minus a half into x plus 1. Then you can simplify this as y minus 2 equals to a half x plus a half, so that you have y equals to a half x plus a half, then minus 2. Then you can simplify this one and get a final answer. This will be plus, yeah, not minus, yeah. So a half plus minus 2, a half plus 2. So this will be y equals to a half x. Is it 5 over 2? When you put them together? Yeah, I guess something like that. So then now, let's now discuss methods of finding derivatives. So methods of evaluating. Is a question? Okay, ask. Where the value of h is just a small change in x. H is just a small change in x. So we are using the definition that the slope which is the same as the derivative at the point, is limit as h approaches 0 of f of a plus h minus f of a divided by h. This is the definition we gave in the previous class on how to find the slope of the tangent, or simply the slope of a curve at a point x equals to a. So the thing we are calling h is a small change in x. So you'll find in some textbooks, instead of writing h, they use delta x. So you'll find so the h is just a small change in the small change in x. Hello, Prof. Okay, fine. Mzuri sana, Prof. Yes, yes, I'm fine. Hey, it was very, very bad. Yeah. No, 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 no. Nilisikia walikuwa wanakata watu huko. Yeah, yeah, and Syrian, they were not fine. Mm, yes, yes, first semester. I sent it to the chairman, yeah, first semester. It was FCE 261. The chairman actually says that we submit all the results to him, and then it's sent to the service department. Yes, Prof. Bado wanatuzungusha tu. Wanasema they were arguing that we are too many. The chairman needs to make some justification, so it's following up. Oh, that was last year. Sasa sisi tuko karibu 40. The whole university, yeah, many departments, yeah. I don't know. I don't know why they are doing that one. This is what Jetpatia Borobado. Oh. Now they going to pay because actually hata wenye like physics wetu walipata lakini wajalipa up to now for first semester. This is just academic year. Oh. Oh, sa. Oh. Oh. Oh, sawa, Prof. Sawa. Okay. Mm. So H is just a small change in X, okay? Yeah, fine. So methods of calculating derivatives. So the first one is what we call first principle. So first principle, although sometimes it's called by definition. So given a function, y equals to f of x, the derivative is f prime of x is limit as h approaches 0 of f of x plus h minus f of x divided by h. Then we usually say provided that this limit exists. So this is how we compute the derivatives by what we call the first principle. It's just the same thing as working out the definition we gave on what a derivative is. So example, calculate the derivative of the following functions. So we begin with an appetizer. Say f of x equals to k, where k is so k is a real number or a real constant. So this we say f prime of x is limit as h approaches 0 of f of x plus h minus f of x over h. Then in this case, f of x is k. This is already given. Then f of x plus h remains to be k because this f of x equals to k is a constant function, doesn't change regardless of the input given. So it remains to be k. So this will mean that the derivative will be limit as h approaches 0. F of x plus h is k. F of x is k, then divided by h. So k minus k is 0. So I'll have limit as h approaches 0 of 0 over h. Then 0 divided by h is 0. So I'll have limit as h approaches 0 of 0, and this will be 0. And we make a generalization from this result that the derivative of a constant always remains to be 0. So in general, the derivative of a constant function is always 0. So that's the first example. And then example 2, the function is f of x is x squared. So here, you start by definition that the derivative is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. Then here, f of x is given by x squared and now we need to define f of x plus h. So f of x plus h will be x plus h squared. So when you square this, we get x squared plus h squared plus 2hx. But you can open the brackets and find that this will be the expansion of that expression. So which implies that the derivative will be limit as h approaches 0 of x squared plus h squared plus 2hx. F of x is x squared, then over h. Then you clearly see that x squared and minus x squared cancels out. So that we'll have limit as h approaches 0 of h squared plus 2hx divided by h. So which method do we use to complete this limit? Which method do we apply to evaluate this limit? Which method? Which method do we use to evaluate this limit? Factorization, correct. So h is common in the numerator, so we'll have limit as h approaches 0, h into h plus 2x divided by h, so that this and this cancels out. So we'll have limit as h approaches 0 of h plus 2x. So when you substitute h for 0, then we have 2x, correct. Because it will be 0 plus 2x, which is 2x. So therefore, the derivative of x squared is 2x. That was number 2. Then 3, if we have f of x equals to square root of x, and then we restrict that this x is always positive for it to be fine. So solution, we say, by definition, the derivative f prime of x is limit as h approaches 0 of f of x plus h minus f of x divided by h. Then here, f of x is given by root x Then once we have f of x, we need to define f of x plus h. So which means f of x plus h is square root of x plus h. Now remember, square root of x plus h cannot be split as root x and root h. It's just actually in the simplest form. So it remains the way it is. So when you replace into the formula, f prime of x will be limit as h approaches 0 of square root of x plus h minus square root of x divided by h. Now, which method do we use to work out this limit? Factorization will give us trouble. Factorization will give us trouble because there's no common factor for root x plus h and root x. Correct, rationalization. So we use rationalization because we can see root function. So we rationalize the numerator. So we write this one as limit as h approaches 0, root x plus h minus root x over h. Then you multiply the numerator and denominator by conjugate of the numerator. And conjugate simply means you rewrite the same terms in the numerator, but change the sign to plus. So we'll have into root x plus h. Then you change this minus to plus root x. Then you do the same thing to the denominator, root x plus h plus root x. So that's what we have. And then once you have this product, the numerator is just as difference of two squares. Like we have is expression of the form a minus b times a plus b, which when you expand, you get a minus b, a plus b gives a squared minus b squared. So when you square this one, when you square a root function, is a very easy expression to work out. It's simply this root sign cancels out. So we'll have x plus h. Then when you square this one, you just get x divided by, this one, don't bother to open the brackets, leave it the way it is. Root x plus h, then plus root x. So we'll have limit as h approaches 0 of x plus h minus x divided by h into root x plus h plus root x. So x and minus x cancels out. So that we have now limit as h approaches 0 of h over h into root x plus h plus root x. Then this h and this h cancels out. So we'll just have limit as h approaches 0 of 1 over square root of x plus h and then plus square root of x. Then here now we can now apply the direct substitution. So which will be 1 over root x plus 0 plus root x. And this will be reduced to x plus 0 is x. So root x plus root x. 2 root x, correct. So therefore, the final answer will be 1 over 2 root x. So this is what you have. Then lastly, that was number 3. Number 4, if our f of x is given by 1 over x, so 1 over x, we do the same process. First, we write the formula that the derivative is limit as h approaches 0 of f of x plus h minus f of x divided by h. Then f of x is given by 1 over x by definition. Then now we define f of x plus h. What will be the value of f of x plus h in this case? Yeah, 1 over x plus h, correct. And it's in the simplest form the way it is. So, which means then the derivative will be limit as h approaches 0 of f of x plus h, which is given by 1 over x plus h minus 1 over x over h. So here what we do, put this as one fraction, write the numerator as one fraction. So 1 over x plus h minus 1 over x will be LCM is x into x plus h. Then x plus h into this LCM is x times 1 is x. Then minus x into the LCM is x plus h, then times 1. So we'll have 1 into x plus h. So what will be the simplified expression of the numerator in this case? This positive h. I'm massing is the h positive or negative? Positive. Do you agree? Is everyone getting the numerator to be positive h? So what is negative 1 times x plus h? Minus x minus h. So then x minus h, what do you get? Yeah, it's negative, not positive. So we'll have negative h over x into x plus h divided by h. So this h here. So this is the limit as h approaches 0 of this expression here. So which will be limit as h approaches 0 of negative h over h times x plus h. Hope you know when you say divide, it's the same as 3. So that this cancels out. So that we'll have limit as h approaches 0 of -1 over x into x plus h. Then when you directly substitute h for 0, what do you get?
-1 over x squared.
Yes, -1 of x squared, because we'll have now x plus 0 is x times x is x squared. So -1 over x squared, correct? So that will be the derivative of that function, 1 over x. Then can you try this? F of x equals to 1 over 2x plus 3. I give you 2 minutes to try this. Follow the same process. Calculate the derivative of 1 over 2x plus 3. What are you getting? What are you getting for the derivative of this function? Over 2x. So I square this. Okay. Is everyone getting the same thing? Okay, good. So then now the second method is what we call the power rule. So the power rule states that for any function of this form, where n is a real number, then f prime of x is given by n x raised power n minus 1. So these are very famous rule that you did in high school, that the derivative of a function x power n, you simply drop the n, then you reduce 1 from the power. So for example, consider these following functions. Find the derivatives. Remember we say dy dx is the same as f prime of x. So find dy dx given that y is x power 3, b, y is given by x, c, y is given by x power minus 4. Let's start with this. So here what we are going to do is to apply the power rule. So in the first question, dy dx will be given by drop the 3, then subtract 1 from the original power 3. So this will give you 3x power 2. Now, in the second question, when we write y equals to x, then by default, the power here is 1. So dy dx will be given by 1, x power 1 minus 1, which is 1 times 1 minus 1 is 0, and x power 0 is 1. So 1 times 1 is 1. Then see the power is minus 4. So I'll say dy dx, you drop minus 4, then you subtract 1 from this minus 4. So it'll be minus 4 x power minus 5, which you may write it as minus 4 over x power 5. Because remember from your Form 2 work, if I have a power minus n, it's the same as 1 over a power n. So these and these are the same. Then can you get dy dx for this fifth root of x? And then y equals to x power 0.7. So fifth root means raise power. One over 5, correct. So therefore, we convert this radical in terms of powers. So this is the same as y equals to x power 1 over 5. So which means dy dx, now you drop the 1 over 5, then 1 over 5, you subtract 1. Now what is 1 over 5 minus 1? Minus 4 over 5. So this will be 1 over 5 x power minus 4 over 5. Then the dy dx for a, you drop the 0.7, then subtract 1 from 0.7. So 0.7 minus 1. Minus 0.3. So therefore, we'll have 0.7 x power minus 0.3. Then f, help me get dy dx of this function, 7x power 4. Can you work out dy dx for 7x power 4? So when you get the answer, you unmute and then say it. 28x cubed, correct. Because what you're going to do here, we are going to have dy dx equals to drop 4. So we'll have 4 times 7, then x power 4 minus 1. So 4 times 7 is 28, then x power 3. Then G, y equals to negative 9x. Can you find the y dx for minus 9x? Minus 9, because now the power of x is just 1. So the same thing as having this implies that dy dx equals to, so there's a 1 here, so 1 times minus 9, then x power 1 minus 1, so which is minus 9, because the x power 0 is just 1. Then the second last example is y equals to 1 over 5 x squared. So how can we write 1 over 5x squared in a form which we can apply power rule directly? Correct. So this can be written as 1 over 5 x power minus 2. Good. So therefore now dy dx will be 1 over 5, then times minus 2, then x power minus 2 minus 1. So which will be given by minus 2 over 5 x power minus 3, or you can write it as minus 2 over 5 x power 3. Then lastly, f of x equals to x cubed. Yes. One over 5 times minus 2. So 1 over 5 times minus 2, the same as minus 2 over 1. So 1 times minus 2 is minus 2. 5 times 1 is 5. Yeah. So it's minus 2 over 5. So this is minus 12x plus 4. Can you find the derivative of this function? I will give you. So 3x squared minus 5, because the derivative of the 4 is 0. Derivative of constant, correct. So the next is what you call the sum and difference rule. The sum and difference rule. So this one says that if, so let u of x and v of x be two differentiable functions of x, Then 1 d dx of u of x plus v of x is the same as du dx plus dv dx, which is the same as u prime plus v prime. So that's what you got the sum rule. And then d dx of u of x minus v of x is du dx minus dv dx, which is u prime minus v prime. So it's a very direct that if you are getting the derivative of sum of two functions is the same as the sum of the derivatives of the respective functions. Similarly, the derivative of the difference of two functions is the same as the difference of the derivatives of the respective functions. So an example, find each of the following. Derivatives so the first one, d dx of the function 5x cubed minus 7, and b d dx of the function 24x minus root x plus 5 over x. So here is just a direct application of the sum and difference rule. So what you do in the first case, so d dx of the function 5x cubed minus 7 is the same as d dx of the first function 5x cubed minus d dx of the second function 7. Then by power rule, when you differentiate 5x squared, x cubed, you get so 15x squared. Then when you differentiate 7, 0. So therefore, the final answer is just 15x squared. So just a very direct the way it is. And then part B, d dx of the function 24x minus root x plus 5 over x. So you supply the derivative to each of the functions or the terms. So this will be d dx of 24x minus d dx of root x plus d dx of 5 over x. So the derivative of 24x minus, now this is the same as x power a half. So when you differentiate x power half, you get a half x power So remember here is the same as having x power half. And then here is the same as having 5x power minus 1. So when you differentiate x power half, you get minus a half x power minus a half, because a half minus 1 is minus a half. Then when you differentiate 5x power minus 1, minus minus 2. Yeah, minus 1 is minus 2. So which is the same thing as just having 24 minus, you can write this one as 1 over 2 root x minus 5 over x squared. So that's what you do for sum rule. So just as an application of this sum and difference rule, consider this question. Find question? Yes. Here, you see, there's for the second term, there's already a minus sign because we had 24x minus root x. So there's already a minus sign here. Then root x is the same as x power half. So when you apply the power rule, you drop the half, and then you subtract 1 from a half. So this is what gave us this term. Sawa. Then now for this other one, when you have 5 over x, it can be written as 5x power minus 1, so that we apply the power rule directly. Yeah. So then now when you now drop the -1, so -1 times 4 is what's giving us minus 5. Okay? Fine, good. So question, which is application of this sum and difference rule. Find the points on the graph of f of x equals to minus x power 3 plus 6x squared, at which the tangent line is horizontal. That's a very good application question. So they're asking us to find points on the graph where the tangent is horizontal. So can you visualize when we say tangent is horizontal, what do you expect to be the value of the derivative? What do you expect? So like, let me draw an arbitrary graph. So for example, if I have this, so if these are an arbitrary function, so at this point, so if this is a tangent, so this tangent is horizontal. So what do you expect to be the value of the derivative at this point? Okay, maybe it's like I'm asking you, what is the gradient or slope of a horizontal line? Or the gradient or slope of a horizontal line? 0, correct. So that's the concept that's being tested here. So then, solution, you'll say the derivative is used to find the slope of a tangent line. This one we know. And a horizontal tangent has slope 0. So that's the key concept there. So therefore, we seek or resolve f prime of x equals to 0. So that's what you are really interested in. Because we know when we get the derivative, then it will give us the gradient function on that curve. And then at a specific point now, when we draw the tangent, if it is horizontal, then the slope must be 0. So then now reduces to finding d dx of this function, which is minus 3x minus x cubed plus 6x squared. And then we equate this one to 0. So what would be the derivative of, okay, maybe let's just apply directly. So this would be the derivative of minus x cubed plus the derivative of 6x squared. This should give us 0. So what is the derivative of the first term? Minus 3x squared. Second term? Positive 12x equals to 0. Then can you solve for x in that equation? Solve for x in that quadratic. X equals to 4. That's the only answer for x. Remember, these are quadratic equation. Quadratic equation has two answers. So the common thing here is minus 3x is common. So x minus 4. So which means minus 3x equals to 0 or x minus 4 equals to 0. So there are two values, x equals to 0 or x equals to 4. I know the 4 answer, you are just simply dividing through, you are taking the minus 3x squared to the opposite side and then dividing by 3x. That is a wrong way of solving the equation. These are quadratic and it has two solutions. So if you give only one answer, you get it wrong. So then now x equals to 0 and x equals to 4. So when x equals to 0, what is f of 0? Remember, f of x is given by minus 3x cubed plus 6x squared. So what is the value of f of 0? 0. So f of 0 will be 0. Then when x equals to 4, what is f of 4? What is it? 32. So therefore, the graph of f of x equals to minus x cubed plus 6x squared has horizontal tangents at the points 0, 0 and 432. Then you get your 2 or 3 marks. Then another example, find the points on the graph of f of x equals to minus x cubed plus 6x squared, at which the tangent line has slope 9. Who can tell us how we need to deal with this problem? Who has an idea on how to deal with this problem? Just unmute and say the answer. The equation itself to 9. So minus x cubed plus 6x squared equals to 9. Okay, that's one way. Any other person with a different opinion? Yeah, you affect the derivative is what you equate to 9, because derivative is what gives the slope, correct? So the solution here, we equate the derivative. I remember the derivative is what gives the slope of the tangent to 9, and then solve. So d dx of minus x cubed plus 6x squared should be equated to 9. So this is the same as d dx minus x cubed plus d dx of 6x squared equals to 9. So this minus 3x squared plus 12x equals to 9. So then now, can you solve this equation and tell me the value of x? And the best way, the easiest way to in fact, you can actually start by dividing through by minus 3. Minus 3 is common, so that we have x squared minus 4x equals to minus 3. So we have the quadratic x squared minus 4x plus 3 equals to 0. So what are the solutions of this quadratic equation? So product in this case is product in this case. Three, sum, -4. So numbers -3 minus 1, correct. So therefore we'll have x squared minus x minus 3x plus 3 equals to 0. So common here is x into x minus 1, then minus 3 into x minus 1 equals to 0. So we have x minus 1, x minus 3 equals to 0. So x equals to 1 or x equals to 3. So when x equals to 1, f of 1 will be remember the f of x in this question is minus x cubed plus 6x squared. 5. And then when x equals to 3, what is f of 3? Then 7, correct. So therefore, the slope of the function f of x, which is minus x cubed plus 6x squared, is 9 at the points 1, 5 and 3, 27. So you should be able to relate the concepts you are doing to other problems involving derivatives. So then next we have the product rule. So the product rule, so we require two differentiable functions, u and v. So let u of x and v of x be two differentiable functions of x. So let u and v be differentiable functions of x. Then the product f of x, which is given by u of x times v of x, is also differentiable with respect to x, and we have d dx of f of x, which is the f prime of x, is the same as du dx times v of x plus dv dx times u of x. So this is usually what we say, we write this one as u prime v plus v prime u. So here we go the product. So the product of uv is the same as u prime v plus v prime u. So let's begin with an appetizer. So find the derivatives of a function h of x, which is given by x squared into 9x plus 2. So here, so you will let this first function to be u, so u of x be x squared, and this second function, call it v of x, 9x plus 2. So with that then, it follows that u prime will be two x and v prime 9, because the derivative of constant 2 is 0, so 9. So h prime of x is given by u prime v plus v prime u. This by definition. So which will give us u prime is 2x times v, which is 9x plus 2, plus v prime, which is 9, times u, which is x squared. So this will give us 2x times 9x is 18x squared. 2x times 2 is 4x. 9 times x squared is 9x squared. Then when you collect like terms, 18x squared plus 9x squared is 27x squared. Then plus 4x. Then example 2, consider the function f of x equals to x squared times e power x. Remember we said lastly that the derivative of exponential is the same exponential. So therefore here, we let u of x be x squared and v of x, let it to be e power x. So which implies u prime of x is given by two x, and v prime is given by e power x remain the same. So by definition, f prime of x is u prime v plus v prime u. So u prime is 2x, v is e power x, v prime is e power x, u is x squared. So this will give you 2x e power x plus x squared e power x. If you like, you can factor out e power x, and they have 2x plus x squared, then e power x. Then I want you to find the derivative of this. The g of x is given by 3x minus 2x squared into 5 plus 4x. And then number 4, find dy dx given y equals to x e power x. I'll give you 2 minutes to try this. So what are you getting as a g prime of x? Minus 20, x plus 15. I have a slightly different answer from yours. Can you check? Check your simplification. Again, it's not, we have different answers. Anyone with a different answer? Yes, that's the correct answer. Minus 24x squared plus 4x plus 15. If you work out correctly, that should be the correct answer. G prime here should be minus 24x squared, then plus 4x plus 15. So ensure that you get this one. You let this one to be your U, this one to be a V. Then what is the Y prime for this? Y prime will be? Correct. 1 plus x into e power x. Correct. Good. So that is how we apply the product rule. Just let one part be u, another one be v, and then the dy dx is given by u prime v plus v prime u. So this is the main take home. So if we have a product rule, then we also must have the other operation quotient rule. So the next is what we call the quotient rule. So when a function f of x turns out to be a structure of a quotient u over v, then this is when this rule is applicable. So it said that if we have two functions u and v, let u of x and v of x, we don't allow it to be two differentiable functions of x. Then the quotient f of x given by u of x over v of x is also differentiable with respect to this variable x, and we have f prime, or the so-called dy dx, is du dx times v minus dv dx times u divided by v of x squared. So which you can write this one in simple terms as u prime v minus v prime u divided by v squared. So this is what we have as our dy dx. So this is a famous quotient rule for differentiation. That you have been asked to differentiate u over v, you simply define u prime v minus v prime u divided by v squared. So e.g., find the derivative of the function f of x is 5x minus 2 divided by x squared plus 1. So remember, when we have this structure, then by default, what is let to be u is the numerator and v is the denominator. So the formula I've given is very specific on what you need to what you let to be u and v. So by default, u is the numerator and v is the denominator. So that's what you have. So once you have u and your v, then the next step is to get their derivatives. So u prime in this case will be 5 and v prime 2x, correct? So therefore, f prime of x or dy dx will be u prime v minus v prime u divided by v squared. Then you substitute accordingly. So we'll have 5 into x squared plus 1 minus v prime, which is 2x. Then u is 5x minus 2 divided by v squared, which is x squared plus 1 square. So let's simplify the numerator. So 5 times x squared is 5x squared. 5 times 1 is 5. Minus 2x times 5x is minus 10x squared. Minus 2x times minus 2 is plus 4x. The denominator, you don't have to open it. Just leave it the way it is. X squared plus 1 square. So collecting like terms, 5x squared minus 10x squared gives minus 5x squared, then plus 4x, and then plus 5, and then divided by x squared plus 1 square. So this will be your dy dx. Then example 2, we have x power 5 over x power 2. We know we can as well simplify and use a power rule, but let's just appreciate the concept of quotient rule. So these are function f of x. So by definition, we let u to be x power 5 and v to be x squared. So which means u prime is 5x power 4 and v prime will be 2x. So by definition, f prime of x is u prime v minus v prime u over v squared. So which will be u prime is 5x power 4, v is x squared, v prime is 2x, u is x power 5, divided by v squared. So you have x squared square. Now what is 5x power 4 times x squared? So 5x power 6, 2x times 5x times x power 5. X power 6. Then what is x squared square? x power 4, correct. Then 5x squared and 2x, 5x power 6 and 2x power 6 are like terms. So when you simplify, you get 3x power 6 over x power 4. Then from loss of indices, x power 6 over x power 4 reduces to 3x squared. So x squared. So this is what you have. Then find dy dx given. So the first function y is tan x. Now, tan in terms of cosine and sine can be written as sine over cos. So therefore, we say y equals to tan x is nothing, which is the same as sine x over cos x. So you let this to be u, let this one to be v. So u prime will be cos x, and v prime minus sine x, correct. So remember, when you differentiate a cos function, you get a negative sine function. That's what you saw from the last class. So by quotient rule, dy dx is u prime v minus v prime u over v squared. So which, when you substitute, u prime is cos x, then v is cos x minus v prime is minus sine x, and then u is sine x. So minus minus is plus. So sine x squared, and then divided by cos x squared. So cos times cos is cos squared. So cos squared x, then plus sine squared x divided by cos squared x. Now cos squared x plus sine squared x is 1. So this will be 1 over cos squared x, and 1 over cos defines which ratio? If you go to your toolbox, when we are discussing the trigonometric functions, 1 over cos defines which ratio? Sec. So therefore, this is the same as sec squared x. So therefore, in general, when y equals to tan x, then dy dx is given by sec squared x. Then second part, y equals to cot x. So you also just express this in terms of sine and cosine. So cot in terms of sine and cosine from your toolbox is the same as 1 over tan. So which means in terms of cosine and sine, So cos x over sin x, correct. So this is by definition. Then you let the numerator to be u. So let u be cos x and v be sin x. So which means then u prime is going to be negative sin x and v prime is going to be cos x. So dy dx is given by u prime v minus v prime u over v squared. So which will be u prime is minus sin x, v is sin x. So I'll have minus sin x squared minus sin x. Let me just write minus sin x times sin x. Then minus v prime is cos x, u is cos x. So I'll have cos x times another cos x divided by the square of v, so sin x squared. So we'll get minus sin squared x minus cos squared x, then over sin x or sin squared x. So minus can be factored in the numerator so that we have minus 1 into sin squared x plus cos squared x divided by sin squared x. Then sin squared x plus squared x is 1. So 1 times minus 1, minus 1. So I'll have minus 1 over sin squared x. But then what is the 1 over sin? Cosec. So therefore this will be negative cosec squared x. So this will be dy dx. So in general, when you differentiate a cos function, you get a negative cosec squared function. So as an exercise, find dy dx when y is sec x. The answer is sec x tan x. So find how this obtained. It's still just application of quotient tool. And then number 2, y is cosec x. And when you work out, you should get negative cosec x cot x. So see how those answers are obtained. So I give a 5 minutes break and then I come to finish. Up. Question 1, okay. This one, okay.